Okay, this is the video recording for the Unit 3.5 Algebra 2 lesson. Okay, so again, it'll be 3 parts. We'll go over the study. We'll go over the answers to the study sheets. We'll work through some problems together in the checkup, and then I will release you. Okay, and again, this one has 2 quizzes here. All right, I'll try to break up and point out the differences between the two. But to remind you, or to start it off, the first one will be on completing the square, and then the second one will be on the advanced version of completing the squares. All right. So let's get started here with 3.5. All right, for the overview here, okay. So what this is talking about is easy. It's talking about if you're given the choice, you're probably going to make something perfect if you can, right? And in this example here, why would you not make something a perfect square if it's possible, right? Because it's easy to factor, as we just found out. If we know it's a perfect square, it's so easy to factor, right? Why not make it simple on ourselves? So the question is how do we make something a perfect square, right? And they joke here, it's simple, just complete the square. Right? So if you look at this picture here, we're going to be adding something to that equation in order to complete it and make it this perfect square. All right? So the 3 objectives for this unit are down here. And again, we have 2 quizzes, the ones on just completing the square in general, and then the advanced version of completing the square. So going to our study here, okay, so completing the square, all right, we talked about this briefly in the last unit and the unit before that, but we have perfect square trinomials, right? And if we can factor it, we can take the square root of both sides, we can make a positive and a negative version of the equation, and then we can solve for each, right? So that's an example here of this first one. All right, same thing, okay? So same thing here. You factor the trinomial expression, take the square root, simplify, solve each equation. All right, it's very repetitive. Same thing over and over and over. Now, it might be this incomplete square, which means it is not exactly perfect. We wish it was, right? But we can, again, add something to it to make it perfect. So for example here, if you look at x squared plus 2x equals 4. All right, it is not exactly a perfect square. And if I move that 4 to the other side, it ends up being x squared plus 2x minus 4, which is not a perfect square either. But the question becomes is what can I add to this to make it a perfect square? Right? What is something that when squared is a perfect square but can add up to equal 2x? Right? It can add up to equal 2x, and hopefully your brain's kind of ticking there. All right? Brain's kind of ticking. Now, this question here is talking about, though, why do I have a question mark on both sides? And the reason that is because if you do something to the left side of the equation, you have to do it to the right side when we are adding or subtracting new things. Right? You got to make sure it's even. We can't just add things out of nowhere. So we've got to make sure our equation is balanced. Our equation is balanced if we're going to change it. So hopefully you're thinking of what the right answer is, but the answer is 1, right? It's 1. Because if I have 1 squared, that equals 1, and 1 plus 1 gives me this 2x, right? So when I look at this, if I add 1 to both sides, right? So if I back it up here, I can add a 1 here and a 1 here, right? 4 plus 1 gives me 5. And then if I look at this, x squared plus 2x plus 1, that makes it now a perfect square trinomial. Okay, a perfect square trinomial, because again, if I factor this out, x plus 1 multiplied by x plus 1 would give me this trinomial. All right, so again, looking at it, we add 1 to both sides of the equation. We can then get this x plus 1 squared equals 5 equation, right? And then we just continue on with what we learned in the last unit. You take the square root, right? You have a positive version and a negative version, and then you solve for both of them. Right? So again, this is all about completing the square. What's going to be added or subtracted from this equation to make it easier for us to factor. All right. So there are numerous examples here where you can add something to solve a perfect square trinomial. So if we look here at example 1, x squared plus 6x equals 5. Well, what is going to be added together? What are 2 numbers that perfectly add together to give you 6x? Well, 6 divided by 2 is 3, right? So 3 times 3 gives you 9. Okay, so I need a 9 here. I need a 9 here, and that's going to give me that perfect square because, again, x squared and 9 the square root of that would be just x and 3. So x and 3. So if I have that guy there, I can take the square root of both sides, set up a positive and a negative version, and then solve accordingly. All right. Same thing here. This one. All right. You can start to notice a pattern. If I look here, 8 divided by 2 gives me 4. 4 squared is 16. Okay, and I'm adding 16 to both sides because, again, it has to be something that when multiplied together is a square, but can be added together to equal this middle factor. All right. Now, I like to point out, I will point out here the last two examples. Okay, so the last two examples. All right, so both of these have 3 factors on the left-hand side. They have 3 factors on the left-hand side. Okay, this first one here, it has a +1. Well, 1 is, yes, it is a perfect square, but it's not something that 1 + 1 is not going to give me 4x in this case. But 2 squared would give me 4, and 2 + 2 would give me 4. So I need this number, instead of being a 1, I need to turn that into a 4. So how I can do that is I can just add 3 to both sides. I can add 3 to both sides. Right? I can add 3 to both sides. That would get me my x squared plus 4x plus 4. Then this is now a perfect square trinomial, and I can solve accordingly. All right? Same thing over here, except for now instead of having a 7 on the right-hand side of the equation, it is now equal to 0. But still, right now, I cannot solve this trinomial, okay? But 10 divided by 2, that's 5, right? And 5 squared gives me 25. And so I need this to be 25, but right now I only have 5. So I just add 20 to both sides, all right? Add 20 to both sides, factor, square root, get the positive, negative version, and then I solve for both x's. All right, and I know that's fast, so take your time to digest this slide on your own here. We'll work through a couple more problems. All right, and I skipped over this in class here. I don't particularly like the algebraic tile tools. They don't work super well for me, okay? But shown below, they're trying to show you that when you add things together, right, you move them around, okay, it's showing you different versions of ways of looking at this, right? So if I even try to, it's not liking me too much here. All right, plus maybe there, 6x and 1 and a 1. Oh, nope, it doesn't match up perfectly. There's still something off here. Right? And if you do this properly, you should end up with a perfect square. So if I keep trying and keep trying and keep trying, eventually, for my luck, I'll end up with a perfect square trinomial, right? But you got to get it perfect. All right? So, moving forward, what it's asking you to do is try to match things up, right? So match these things up until it ends up filling in the shape. So right now, this is like our puzzle piece here. So what can we add that's going to perfectly fit in this shape? And like I told you, I'm not the best here with these little algebraic tile tools. But if I layer them up, layer 3, 4, there we go. Moving, right? We're filling it in to complete this square, right? So we had to add 9. Okay, we can add 9 and it now completes this square, right? And so that's kind of how they want you to think about this here. All right, so we added 9 to both sides, right? So now we can complete the square. So if I back this up here, all right, my original equation here was x squared plus 6x equals 7. Okay, and we found out that I have to add 9 of these single tiles in order to fill this and make this a square. Okay, I have to add 9 to make this a square. But again, I have to add 9 to the left side and I have to add 9 to the right side. So when I do that, I add 9 to both sides, right? That then now completes this left-hand side. So this square is now complete. Okay, and that gives me x plus 3 squared and 16. All right, now I take the square root, right? I take the square root, and this one, however, is a little bit different, right? So we actually can take the square root of 16. So the square root of 16 is 4. But now I have a positive version and a negative version. So it's just slightly different. Now we got rid of that square root. But this is a whole lot easier to solve. Now we have x equals 1 and x equals negative 7, right? Because we subtracted 3 from both sides of the equation. All right? Same thing here for the algebraic tile tools. All right, so there. I completed the square. All right, and when I completed the square, right, it's like saying x plus 1 multiplied by x plus 1, right? That's what this little shape is looking like here. All right. Same thing if you go down here. Nope. 1, 2, 3, 4. Okay. So I've got that one. X squared plus 4x plus 4. All right. Same thing. 1, 2, 3. This one's going to end up being 9 again. Okay. All right. And again, some of these get really, really involved. This one is now 16. Okay, so if you're able to do this and you like these, there's plenty of examples for you, okay? But basically, again, you're adding something to fill in that missing piece of the puzzle. All right, so this is what that ends up looking like, right? So we start off here with our original x squared plus 2x equals 8, but we've now added 1 to complete that square, so we got to add 1 to both sides. Add 1 to both sides. Same thing here. We were missing 4, so we added it to both sides. All right, and now once we've completed the squares, we are then able to factor. Okay, we can factor, we can separate into two equations, and we can solve from there. All right, now to complete the square, you have to add a number to blank sides of the equation so that it's a perfect square trinomial. I wish it was only 1. We got to add it to both. We've got to keep it even. All right, and what does it mean to complete the square? It means that you add a number. You add a number in order to fill that trinomial to now make it this perfect square. All right, and again, this first half here, okay, we're at the confirm. This first half here is going to be what's looking at your first quiz. All right, now again, completing the square using these tiles. All right, so what must be added? So you would count up all these little ones. So you got 1, 2, 3, 4, 5, 6, 7, 8. You'd have 8 by 8, which is 64. Let me double check that. Sorry. Yep, 64. 8 by 8, that would be 64. So I'd have to add 64 to both sides of this equation here. All right, so again, you might have something like this on your quiz. Okay, you do not have to use the tile tool if you do not want to. Okay, it says if you need it. If you need to, you can use it. So if this is on your quiz, please don't feel pressured to have to use it. Okay, regardless, you can do this without it, right? I have a x squared and an 8x. Okay, I've got to add something to both sides. Well, 8 divided by 2 gives me 4. 4 squared is 16, so I'm going to end up having 16 to each side, okay? And again, if you want to see what that looks like with your square tool, 2, there we go, 3, 4, 1. It's not that me and the square tile tool don't get along very well here. Okay, so again, you can use the square tile tool if you like. Again, me and him don't get along super well, so I don't prefer to use it. But if you like it, you can. All right. Same thing though. It's asking you just to be able to complete the square. So if you can do that without the tile tools, you are good to rock and roll here. All right, and looking at this one example here, because it's in words, before you complete the square for the equation x squared plus 4x minus 3 equals 0, what operation must you perform? We got to decide what number completes the square, right? You got to decide what number completes the square. Before we start adding or subtracting things, we got to figure out what completes the square here. All right, so let me see if that's the right answer. Incorrect. Before deciding to complete the squares, we got to move the constant to the other side. All right, so we'll move the constant to the other side. Okay. All right, we will move the constant to the other side. So we'll add 3 to both sides here, okay? But I will argue with Apex on this one, all right? What they're saying is because it's a -3, you're automatically going to move it to the other side because this 3 cannot be a perfect square. However, if this was a +3, right, we would first figure out, okay, well, do I need to add values or subtract values? Because you don't want to be moving too many things around if you don't have to. Okay. All right. So then here's some more examples here. And again, I already kind of gave you this answer, but we've noticed a pattern here with how we complete the square, right? So we take that middle number and we divide it by 2, right? And then we square that resulting number, right? So for example here, 2 divided by 2 gives us 1. 1 squared is still 1. All right, that one's not very difficult, but something like this guy might be. So 10 divided by 2 is 5. 5 squared gives us 25, or even better. Okay, 20 divided by 2 is 10. 10 squared is 100, right? So we're noticing a pattern here in how we're going to complete the squares. All right, and this is super, super important, so write this guy down here. Okay, rules for completing the square. There it is. Okay, for any polynomial in the form x squared plus bx, you can complete the square by dividing b by 2 and then squaring that answer. All right, so for example here, if we start with the expression x squared plus bx, okay, we can add b over 2 squared, right? When we factor it, it gives us x plus b over 2 and x plus b over 2, or x plus b over 2 squared, right? Then when we had our other equal sign, we would square root, right? We would square root, we would make 2 equations, and we would execute. All right, but that would be how you complete the square here. You go from x squared plus bx to x plus b over 2 squared. All right, so again, keeping that in mind here, you're going to take 14 divided by 2 is 7. 7 times 7 is 49. Okay, and this one you can't do, I believe, because it's a drag and drop, so I'll do it for you. Okay, we've got x plus 2. Or sorry, x squared plus 8x plus blank. So 8 divided by 2 is 4. 4 squared is 16. All right, and then this one, x squared plus 30x plus blank. So 30 divided by 2 is 15. 15 squared is 225. Okay, so that's how we would complete the squares. All right, so again, it would look something like this. All right, and you can do these coefficients even if b is not an even number, right? So 3 halves, right? 7 halves, 5 halves, right? And you don't have to simplify it more than that, because remember, regardless of whatever is this term, you're going to end up putting it as x plus 5 over 2, right? X over that new term, and then that whole quantity gets squared. All right. Again, completing the square also works for the coefficient if the x term is negative. Right? Because you still do 4 divided by 2. Okay, 4 divided by 2 is -2. Right? It's -2. -2 squared still gives you 4. All right, so it would still be though x minus 2 squared. All right. For this one, it's -6, right? It's -6. You could still do 6 divided by 2 is 3, right? -3, and -3 times -3 still gives you 9. So you can still complete the square. It just depends on if this inner number is now going to be a +3 or a -3. All right, so we're going to now complete the square, okay? So we're going to complete it into a perfect square. So I've got x squared plus 4x equals 12. Okay, x squared plus 4x equals 12. All right, so I'm going to take this number. I'm going to go 4 divided by 2 gives me 2. 2 squared is 4. So I'm going to add 4 to both sides. Okay, I'm going to add 4 to both sides. Then I'm going to simplify by combining like terms. So x squared plus 4x plus 4 equals 16. Now I'm going to factor the left side, okay? And we just told you what it is. It should be x plus 2, right? X plus 2. I've got 2 of those, so this ends up being x plus 2 squared equals 16. All right? And then here we're going to take the square root of both sides. So x plus 2 is equal to plus or minus the square root of 16, which is 4, right? So then we set up two equations. We've got a -4 and a +4, and then we solve for both. Okay, so we end up getting x is equal to 2 or x is equal to -6. Both of those answers are correct. All right. Again, same thing here. Okay, so same thing here. We will add 5 though to start off. Since this is a negative number here, we'll add 5 to both sides so we can start off with a clean slate on the left. All right, add 5 to both sides. That gives us 9 on the right-hand side. Now we look at that b value. So 8 divided by 2 is 4. 4 squared is 16. So we got to add 16 to both sides. All right, add 16 to both sides. Then we're going to simplify. So x squared plus 8x plus 16 equals 25. All right, so factoring the left-hand side, that's x plus 4 squared, still equal to 25. All right, now we're going to take the square root of both sides, and the square root of 25 is actually 5, so this makes this even easier. So we've got x plus 4 is equal to plus or minus the square root of 25, which is 5. All right, so we set up our two equations here. Sorry, let me back that up. Set up our two equations. X plus 4 equals 5, or x plus 4 equals -5. And then when we solve for both of those, we get x equals 1 or x equals -9. All right. Last one here. Last one. We get 3 on the other side. Okay, so let's get rid of that 3. So we've got x squared minus 12x equals 4. All right. Then we realize, hey, we got to complete the square. So -12 divided by 2 is -6. -6 squared still gives us 36. We're going to add 36 to both sides. All right. And then we are going to simplify. We can simplify here by adding 4 and 36. That gives us 40. All right. When we factor the left-hand side, we just said it's going to be x minus 6 times x minus 6. That gives us x minus 6 squared equals 40. All right. Now we take the square root of both sides, and unfortunately this isn't a super nice one, but we end up with x minus 6 is equal to the plus or minus the square root of 40. All right, and so we still know what to do. We set up two equations, a positive version and a negative version. We solve for each. Okay, we solve for each. All right, and this final solutions are as follows, right? So square root of 40 plus 6 or negative square root of 40 plus 6. Both of those are completely fine. And no, you do not need to simplify beyond negative square root of 40. Okay? So setting up the equation, all right? So we'll just go with what Apex is telling us, right? It seems to be the simplest here. What's the first thing that needs to be done? Add 7 to both sides, right? Get 7 on the other side so that we're dealing with a clean slate here. All right, now once it's on the other side, what number should be used to complete the square? Okay, that would be 9 divided by 2, okay, and then squared. So this would look like that, 9 over 2 squared. Okay, you could also put it in parentheses. If it's a fraction and we want to be specific, then you should put this in parentheses, okay? So that's a good sample response here, okay? So I believe if I were to type this into the computer the way that I have it, I believe that would actually be incorrect, okay? Because it would be order of operations. So we got to make sure that this is in parentheses, okay? So if I come back here, we got to make sure add 7 to both sides. Awesome. And we got to make sure that since it's 9 over 2, that whole thing is squared. We got to make sure we write it as such, okay? Because I believe the way that I wrote it originally, the computer would look at that as 9 divided by 2 to the power of 2. So it would look at it like that, right? Which is not the same thing. All right. So moving forward here, okay? This one here is giving, is finding an actual answer to this. So it looks like here, every gap is x. So you've got x here, x there, x there, x there. So it's asking you, given the dimensions, figure out the dimensions. So we actually have our length is 13 plus x plus x. So it should be 13 plus 2x, right? My width is 10 plus x, so it should be plus 2x, okay? And then it says write a function for the area of the canvas and the frame combined. In other words, write a function of the area of the shaded region. Okay, so it would be 13 plus 2x multiplied by 10 plus 2x, right? So it would be this guy, right? We're going to just take both of those, right? Because when we have an area, it's length times width. So that's your length and that's your width. All right. And then if we're looking at just the inside, okay, if we're looking at just the inside, if the area is equal to this whole thing, then the area for the frame alone would be this minus whatever 13 times 10 is, so minus 130, right? So we would square that guy back out, okay? But when we square it out, it's not just this, because we got to remember, we have the 13 times by the 10, okay? What is the function for the area of the frame alone? Okay, so we'd have to be really careful. All right, when you complete the square, you add the square of half of the coefficient of the second, right? So that's that b divided by 2, and then we square that. All right, so b divided by 2, and then we square it. So that's going to be really helpful here moving forward. All right, so 18 divided by 2, 9. 9 squared, 81. Okay. Negative 6 divided by 2. Okay, negative 6 divided by 2 is negative 3. Negative 3 squared is still 9. Okay. And there's a couple more problems that I will let you guys do on your own here. All right. All right, so again, this is the check your understanding for that second quiz, all right? Making sure that you can solve this. So for this one, you're just going to add a value to both sides, right? So 6 divided by 2, then square that number, all right? Same thing, complete the square here the normal way. Now, before you can start this one, right, we got to move 4 to the other side. So move 4 to the other side, then complete the square. Then once you complete the square, you're going to solve it, right? And just to be clear, totally clear on what this is going to look like here. All right. When you get an answer, okay, so when you get an answer, when you get an answer, if the answer is 9 plus square root of 12 and 9 minus square root of 12, this is both of those answers, okay? So when it says plus or minus, it's just like how we've been splitting. So this actually stands for 9 plus the square root of 12 and 9 minus the square root of 12. All right, so if you see something that looks like these guys, that means it is two answers. It's 12 plus square root of 21 and 12 minus the square root of 21. Okay, same thing here. Don't let this confuse you. Plus or minus means you've got two answers there. You've got the positive added part and you've got the negative added part. All right, so again, completing the square, take a minute here, go through these flashcards, but pretty much it is just figuring out how we can make this easier for us to solve the quadratic. All right, now moving on to part 2, our study guide here. Okay, moving on to part 2. Again, if we look at the answers here, it's going to tell you what pages, so please refer back to that if you get stuck or are confused with anything that we have to do here. All right, but first one here, completing the squares, it's a method for solving quadratic equations, right? You add a number to both sides to make sure it is a perfect square trinomial, right? And this is the biggest thing that you should know or have handy, all right? The rule is that C is B divided by 2, and then you square that answer, all right? So for instance here, B is 6, right? B is 6, so 6 divided by 2, and then you square that. So 3 squared is 9, so you would add 9 here to complete that square. Okay, B is 3, so 3 divided by 2, and then you would square that, right? So you can plug this into your calculator to get that 9/4, to get that 9 over 4. All right. Complete the square of each polynomial, all right? So this is just another way of seeing it. This is just another way of seeing it here, okay? So again, same thing. You've got 6x, right? So 6 divided by 2 is 3. 3 squared is 9, right? And then you take it one step further here, okay? So what that ends up being is x plus 3 quantity squared. Okay, same thing here, 9/4, which is what we have in the full equation, but when we actually are looking at just the factors of that, okay, just the factors, it's x plus 3/2 quantity squared. Okay, so then here's the whole thing put together, how to solve it step by step. You add b over 2 squared to both sides. We factor the perfect square trinomial. We take the square roots of both sides. You have a positive version and a negative version, right? You have a positive version and you have a negative version, and then you solve for both equations. All right, and then you use substitution to check to make sure your solutions are correct, right? So I plug 1 in to the equation, solve, make sure that 7 equals 7, right? Same thing here. I'm going to plug in -7, and I got to make sure that at the end I've got 7 equals 7. All right, and that's the entire study guide here for 3.5. All right, so if we continue on here, we're going to go to the next part here, which is our checkup. But again, I just want to remind you while I'm here, 2 quizzes, completing the square standard and completing the square advanced, right? So again, take a look back at this study. Again, it's broken into 2 parts depending on those multiple choice sections. So again, choose how you want to take it, but I prefer to work on section by section to make sure I totally understand what's going on here. All right, looking at our checkup now. Okay, we'll work through some of these problems. Again, all the answers are posted on Google Classroom for you. But we'll go through this 3.52 practice problems right now. Okay, so we're going to go through some of these. Again, you can work on the rest of these on your own or take a look at the answer key, whatever you feel most comfortable with. All right, now for questions 1 through 3, we're going to find the number that should be added to both sides of the equation. So I'm going to do number 1 and number 3 here. So again, the key is that c is equal to b divided by 2, and then we square that number. So the first thing you might want to do is figure out what b is. So for this first one, b is equal to 6. So c is equal to 6 over 2, and then square that. Also known as 3 squared, also known as 9, right? So we would add 9 to both sides, right? And we're just going to stop there because that's all it's asking us for, is find the number that should be added. So we should add 9 to both sides. All right, for this one here, b is equal to 8. b is equal to 8, so I've got 8 divided by 2, and then that would get squared. So like saying 4 squared, which is 16. So I would add 16 to both sides of that. All right, now for the next numbers here, 4 through 10, complete the square and find all of the solutions to the equation. So again, completing the square, the trick is that c is equal to b over 2 squared. b over 2 squared. All right, so let's pick a couple of these here. All right, first off, let's do number 4. So again, we just figured out that if I have 8, right, and maybe I'll take this a little bit slower here. Okay, for c, it's 8 divided by 2 and then square. So 4 squared, which is 16. So I need to add 16 to both sides, equals 10 plus 16. So now I'm going to simplify. X squared plus 8x plus 16 equals 26. All right. Okay, now I'm going to factor. I know that this is going to be x plus 4 and x plus 4 equal to 26. Or another way of saying that is x plus 4 squared equals 26. All right, now I take the square roots of both sides. So I'm left with x plus 4 equals the square root of 26. All right, and that is a positive version and a negative version. So I look at it, I've got x plus 4 is equal to positive square root of 6, and x plus 4 is equal to negative square root of 26. In both cases, I'm going to subtract 4 from both sides, and for the sake of space, I'm going to erase that here. Okay, so I'm left with x is equal to square root of 26 minus 4, and x is equal to negative square root of 26 minus 4. All right. Another way that you might see that on your test is negative 4 plus or minus the square root of 26. Plus or minus the square root. All right, moving on down to the next one here. Let me move some of this for the sake of space. All right, so moving down to this next one. Maybe let's do number 7 here, okay? So this is not a perfect square at the moment, but we can turn it into one by moving this constant to the other side, right? So we're going to subtract 10 from both sides. All right, so I'm left with x squared plus 6x equals 7. All right, remember, we're going to add something here. We're going to add something to both sides to complete that perfect trinomial. So the question is what are we going to add? Well, c is equal to our b value, which is 6 divided by 2, and then we're going to square that. So otherwise saying 3 squared, which is known as 9. Okay, so we change the equation. X squared plus 6x plus 9 is equal to 7 plus 9. Okay, so even further, 6x plus 9 is equal to 16. All right, and then we're going to factor this guy. We know that this is x plus 3 squared equals 16. Okay, now when we take the square root of this one actually becomes super nice because we have x plus 3 is equal to plus or minus 4, right? Because the square root of 16 is 4. So we set up our two equations. X plus 3 equals positive 4 and x plus 3 equals negative 4. All right, so I'm left with x equals 1 because I subtract 3, and I'm left with x equals negative 7. So those are my two answers. All right, and then again, if we want to check them, we plug them back into the original, and we should end up getting 17 equals 17 for both of those answers. All right, then we can do, let's go with one more here. All right, let's go with one more here. Let's maybe just pick number 10 because we can. All right, so again, we're going to start off by moving this constant to the other side. So minus 40 to the other side. So x squared minus 14x equals negative 45. All right, negative 45. Okay. Now, the next thing here is we've got to figure out what our c value, sorry, I shouldn't have wrote x, should have wrote c. Our c value is equal to, again, b divided by 2, and then we're going to square that. Okay, so that's what that is equal to. So, for example, our b value is negative 14. Okay, negative 14 divided by 2, and then we're going to square that guy, also known as negative 7 squared, also known as 49. All right, 49. So what we're going to do is add 49 to both sides. Minus 14x plus 49 equals negative 45 plus 49. All right. Now we're left with x squared minus 14x plus 49 equals 4. All right. And again, I want to pay special attention to the fact that this is minus 14. Okay, minus 14. So it is now x minus 7 times by x minus 7, and that gives us 4. All right, simplify this further. X minus 7 squared equals 4. Okay, then we're going to take the square root of both sides. So this ends up being x minus 7 equals plus or minus, and the square root of 4 is 2. So this actually ends up again being nice. We have x minus 7 equals positive 2, and x minus 7 equals negative 2. All right, so we plus 7 to both sides, and I'm left with x equals 9 and x equals 5. All right, so those are my two final answers there. Again, you can plug them back into the original, and you should end up getting negative 5 equal to negative 5 if you are correct here. All right, again, I left a couple problems for you to be able to do, and again,